Okay, good morning. Today I'm going to make sure just to kind of go over your practice test as if you came to Math Lab, and I'm going to answer all your questions. So as you're going through this video, if you don't need help with number 1 or 2 or 3, then when you see that I put number 1 and I erase it, that means I'm done with that one. So just look for the number that you're looking for on the video. You can kind of zoom through it, and then the question that you have, you can listen to the explanation. So you don't have to listen to the whole video if you don't need it. All right, here we go. So number 1. Here we go. Number 1 is basically a triangle. All right. And you have the hypotenuse 15 and you have the leg here 12. And we need to find the area. Well, the area of a triangle you must have memorized is half base times height. Some of you may remember it as base times height divided by 2. The problem here is I have the base, but I don't have the height. So I'm going to call that x. And in order to find that, I'm going to use the Pythagorean theorem, which says x squared, leg squared, plus leg squared, which is 12 squared, equals hypotenuse squared, which is 15 squared. Now, x squared plus 144 equals 225. If you subtract 144 from both sides, you're going to get x squared equals 1 and 8. So 81. If you take the square root of that, then we know that x equals, well, we can now change that from x to 9. All right, and so here we go. I'll put 9 here. Well, now I'm able to follow this formula. Area equals half times base times height. So half, the base is 12, times the height, which is 9. So half of 12 is 6, and 6 times 9 is 54. And then go back and always look for the units, and it looks like it's centimeters, so it's centimeters squared, and this would be the answer, C. All right, now we'll go to number 2. Number 2, it says a parallelogram. I'll draw a quick parallelogram here. The traditional looking parallelogram. It has a base of 10 inches. It has an area that is 80 inches squared, or square inches. And it says, what is the height? This is what they don't know. Well, to find the area of a parallelogram, you need to have it memorized. That's just base times height. So we know the base is 10. We don't know height. We'll call that x. And we know that this equals, if I multiply 10 times x, that I would get 80. Divided by 10, x is equal to 8. Well, 8 was the height. So 8, and the units is inches, is your answer. And that is B on number 2. Now let's go to number 3. Number 3 says the area of a rhombus. A rhombus is a square that's been pushed over by a bully. So it's a square, but it's not a square. Okay, there we go. That's sort of a rhombus. If one of the diagonals is 8 centimeters and the other is 10, so this is the 8 and this is the 10. So one is 8 and the other is 10. Okay, then what's the area? Well, the area for rhombus and for a kite, they are both diagonal 1 times the diagonal 2. Basically, take the two diagonals, multiply them, and divide by 2. You could also see this as half diagonal 1 times diagonal 2. Either way, they give us diagonal 1. They give us diagonal 2, which is 8 times 10 over 2. The answer here is 40, and then look again for the units, centimeters squared. This is C for number 3. Number 4. A trapezoid. All right, on this trapezoid, you have one base that's a 6, the other base is 10, and the height is 4 centimeters. We're looking for the area. Well, again, this is another formula. It's half base times height, but the base, they have 2 bases with a trapezoid, so it's base 1 plus base 2, so you get the full base. All right, so with that, let's fill in. We have everything we need. We have half, we have base 1, which I'm going to call 6, base 2, I'm going to call 10. You could reverse the order and you'd get the same thing. And then the height is 4. Well, half of 16 is 8, and 8 times 4 is 32. And then look again for the units. It is centimeters squared, which is the letter B for number 4. Let's go to number 5. Number 5, area of a kite. Remember that I said with a kite, the area of a kite, all right, is diagonal 1 times diagonal 2 divided by 2. In the picture for number 5, you have both diagonals. It gives you that one diagonal is 14. And it gives you the other diagonal is 17. So let's just fill them in. You got 14 times 17 divided by 2. And this would be 70, I believe that would be 168 inches squared. All right. Because that'd be 7 times 70 and 49. Maybe it's not. 70 and 49. Okay, correction. Let's erase that. Multiplication says that instead that is 119 inches squared. Sorry, I didn't have my calc. I will fix that problem though. We'll get a calc. So the answer is 119, and that would be the letter B. All right, so for number 5, the answer is B. Okay, now let's go to 6. Number 6, you have the area of a square. So a square, we know about a square is that all sides are equal, but the area is equal to 36 inches squared. Well, if I know the area is 36, we also know that area is equal to base times base, or base times height. But since it's the same, some would even say it's the same thing as side squared. So if I take the square root of 36 and the square root of that, you're going to get that the side lengths are 6, because 6 times 6, base times height, is equal to 36. Now the actual question asks for what's the perimeter? Well, the perimeter is at all sides. So technically it's 6 plus 6 plus 6 plus 6, or you could do 6 times 4, because when you add 6 4 times, that's what you're doing. And you get the answer is 24. And again, look at the units, inches, and it asks for perimeter. So it's not squared. Notice not squared because perimeter is not in square units. All right, the answer for this is the letter D. We'll go to 7. 7, you have a circle. It asks for the circumference. It gives us that the radius is 6. The circumference of a circle, you have 2 options. You have 2 pi r or pi d. If I'm given radius, though, I'm going to choose to use this one. So 2 pi times 6. Well, it says to leave the answer in terms of pi. So that means we will not type pi in your calculator. However, you will multiply 2 times 6 in your calculator, and you'll get 12 pi. And again, look for the units. It's centimeters. And circumference is like perimeter. It is not going to be units squared. Okay, it's just going to be units, centimeters. All right, now we'll go to number 8. Number 8, we have a circle. This time it gives us the diameter is 10 centimeters. Oopsie, sorry about that. And then they want us to find the area. Well, the area only has one formula. That's pi r squared. So we have to find the radius. If the diameter from here to here is 10, the radius is from here to here, which is half of 10. So 10 divided by 2, 5. The radius is 5. Now we'll plug that in for pi. Pi, 5 squared, which 5 squared is 25. So it's 25 pi. And then we'll look for the units, centimeters squared. And again, that is the answer, B, and units are squared like before because we're back in area. Now we'll go to 9. 9, you have this square, okay? It kind of shows you, I think it's called an apothem for this shape as well, but it's the same idea of that. Except for if this is if this is the midpoint of the square, then we know that the distance from here to here is the same as the distance from here to here. So that means this is also 6. Well, if this is 6, then we also know this is 6 plus 6, 12. Well, one thing we know about squares, that's 12 and that's 12. So we got to find the area. Well, the area of a square is base times height, or side squared. So that's 12 times 12, which is 144 centimeters squared. All right, we're going to go ahead and do, this is number 10, okay? And so there we go. I have the picture drawn here for you as you will have on your test. And you may write on your test on these, so that way you don't have to redraw the picture. For this one, I think, oh, there's so many different ways to do this. I'm going to choose to draw the line that way right there. So I have a 8 by 5, which is 40 right here. I have a, well, the distance is 20 here, and this, if this whole thing is 10, and this little piece here is 5, then this must be 5. So this is 20 times 5, which is 100. And then we have this little triangle. Okay, oh, wait, that's wrong. Base You want me to tell you why that's wrong? Because what I just realized, as soon as I got ready to tell me, hey, what's this distance over here for this piece of this triangle, I realized, wait, 20 included that. So I've got to go back and think, okay, so if 20 included that, what is the distance from here to here? Well, I know the distance all the way from here all the way down to the end is 20. I also know the distance from here to here is 8, but I also know from here to here is 8. So that means that the distance from, changing the color so we make sure we make this clear, the distance from here to here must be 8 plus 8 or 16. So this little rectangle here is a 16 times 5, which is 80. All right, so we have 80 there. And then finally, we have our triangle. Well, if the whole distance on the top is 20 and this green distance here is 16, then what is left is 4. All right, and we'll choose to go back to another color here, 4. And then the height of this triangle is 5. Okay, and you can see that over here where it is the height of this rectangle. So this is 5. And so the area of a triangle is 1/2 base times height. So that would be 2 times 5, which is 10. So again, trying to make sure these are clear. I'll put 10 here. So now we're going to need to add the 3 values that we have. I don't think white's going to show up. No, I didn't think so. Okay, purple. We got a 10 here. We've got 80. We've got 40. If you add those 3 values, 10 plus 40 plus 80, you should get 130. Then go look at the units, centimeters squared, because we are talking about area. So the answer for this is A. All right, let's go to another one. Okay, number 11. I am not going to attempt to draw 11. It is this little heart shape, and it has like extra little shaded wings or something right here, okay? When you count all the squares, that's all you need to do. Now, there is an important part here I'll point out. On this, to the best of my ability, I will draw it here, okay? You have this little thing, okay? You may have struggles with knowing, hey, how much of that do I count? I mean, it's got some of the piece, but not all of it, like right here, okay? This would probably count as like 1/2 and 1/2, and then we'll just say that this kind of counts as part of that section there, okay? And this heart really goes all the way out like this, okay? So this would count as 1, and then you have 1 on this side. So this is 1, and that is 1. And then the other parts where we have 1 here and 1 here. And then again, on the bottom of this little heart, okay? And I know this is scratchy looking, but you can see what I'm talking about on your paper. You have, again, like what, 1/2 and 1/2. Okay, it's not a whole square. So the total here would be 1, 2, 3, 4, and 5. Now, I believe that is correct. Let me count again. 1, 2, 3, 4, 5. Ooh, wait, there's some more wing spots right here. So right here is a little spot, and here's a little spot. And again, you can see that's 1/2 and 1/2. So that makes it, I believe, 6. And so our total is 6 inches squared. So just be really careful to count as you go, like I did here with 1/2 and 1/2, and then 1/2 and 1/2. Then go to the next level down. Okay, this little 1/2 and this little 1/2. Okay, so that's 1 and 2, 3. And so it's just a matter of counting them. So hopefully you're not having too much troubles with knowing how to count the squares. If you just try to do it one little piece at a time. All right, now let's go to number 12. All right, 12, you have, it says there is a perimeter of a square. On this square, they give us that D is 0, 0. So this is D. They tell us that E is 5, 0. So 1, 2, 3, 4, 5. They also told us, by the way, that this is a square. Well, if this side right here is 5, then we know that this side would be 5, and this side would be 5, and this side would be 5. That's the nature of a square. So now it asks for the perimeter. So therefore, guess what? It is 5 plus 5 plus 5 plus 5. Or if you're adding 5 4 times, it's the same thing as 5 times 4, or 20. And again, this doesn't actually have centimeters or whatever, so you just call it units squared. And that's how you find the area.
Notice they did give you units squared and regular units on that one, so be careful.
Oh, yes. Units squared. Area is squared. What am I finding? Oh, area is squared. Okay, very important. But perimeter, not. So oops. So make sure you don't make that mistake. It'd really be a shame to know how to do this and then mess up on the units. So always, I would honestly get done with my test and I would go through every single problem that has units on it and make sure that circumference and perimeter do not have squared on them. Just go there and say, did it ask me for circumference or did it ask me for perimeter? If it did, make sure you did not answer with square units. Okay, now let's go to the next one. Oh, D. All righty. 13. 13 is another one you get to plot points. Go ahead and plot points on your test. I think it'd make it a lot easier. Go -4 and 2. That is W. Then we'll do 1, 2. 1, 2. And this is X. And then we'll do 1, -2. And this is a Y. And then we'll do -4, 0. And this is Z. And this will make a lovely, beautiful, one-of-a-kind trapezoid. Mostly I'm calling it beautiful because it kills my time. All right, so now let's find the area. So we'll have unit squared, by the way. All right, so the distance along this is 1, 2, 3, 4, 5. The distance here is 1, 2, 3, 4. The distance here is 1, 2. You do this on graph paper, which you will on your test, that'll make things nice. By the way, we can't find this distance, but then the question is, do we need it? Here's the area, half base plus base times height. All right, so bases, the bases on this, okay, this is important. The bases are 4 and 2. No, it is not laying down on the bases. Okay, that's important to recognize. But for a trapezoid, the bases are the ones that are parallel. All right, the parallel sides are the bases. So you'll have half, 2 plus 4 times a height of 5. Well, that's 6, and half of 6 is 3, and 3 times 5 is 15 units squared, which is the letter A. All right. Next. All right, now we are on number 14. Okay, it says the radius of a circle is multiplied by 4. Okay, so let me make sure I point this out. If you are going to multiply the radius by times 4, okay, and you're looking at circumference, one thing you can say for sure, radius multiplied by 4. Sorry, that is the sloppiest I've done in a while. I'm going to fix that because that just drives me crazy. All right. The radius times 4. With circumference, that means the circumference is times 4 is also. It's always that way because circumference is 2 pi r. There's no way for this radius to become squared or anything else. It's just going to be 4 times larger. Okay, so if I'm multiplying and I'm talking about circumference, it's going to be 4 times larger, okay? However, if I'm talking about the radius and we're talking about area being 4 times, area, well, area is going to be squared times larger. And the reason why is, again, think about area is pi r squared. Oh, r is going to be squared. So if I'm looking at this, then area, since it's talking about area and I'm looking at the radius, I'm going to go, what's 4 squared? Oh, it's 16 times larger. So with area, you're going to square the r and say it's that many times larger. With circumference, you're going to just say it is that many, whatever number. It could be r is 10 times multiplied by 10. Then the circumference would be 10 times larger and the area would be 10 squared, 100 times larger. Okay, so that's how this works. With this one, now let's read what it says. A, circumference is multiplied by 4. Well, that's true. Definitely A is true. Okay, now let's look at B. B says area is multiplied by 4. No, area would be 4 squared. That's 16 times larger, so B is incorrect. C, circumference is multiplied by 16. No, remember we just said circumference is going to be what it is. And so it is that we just turned the page and I lost them. I touched it by accident. Okay, sorry about that. We lost the screen. Okay, so now we should be able to move on to 15. All right, so 15, here we go. 15, the statement accurately describes the result of doubling the height of a rectangle. Well, again, think about a rectangle. If I'm going to take, and here is the height, let's just take and create two numbers. Let's go with 2 and 4. Those are great numbers. If we are going to double the height, well, instead of it being 2, it would now be 4. And of course, my picture is not drawn to scale, just pretend. All right, now, if I do this, is the perimeter doubled? Well, what would be the perimeter of this first rectangle? This is 2 and this is 4. So 4 plus 2 is 6 and 6 more is 12 is the perimeter. The perimeter on this one, okay, well, it's all 4. So 4 plus 4 is 8 and then the perimeter would be 16. So the question is the perimeter doubled? Not that I checked. 12 times 2 would be 24. So A is incorrect. B, is the area multiplied by 4? Well, let's compare the areas. The area of the first one is 4 times 2 is 8. The area of the second one is 4 times 4 is 16. Is the area multiplied by 4? No, that is not correct as well either, because it would be 8 times 2. The letter C, area is doubled. Yes, that is correct. Area is doubled, that is C. And the perimeter is tripled. Well, clearly, no, not tripled, because 12 times 3 is not 16. So the answer is C for 15. All right, let's go to 16. On 16, you have the perimeter of what is the perimeter and area of a triangle? And they give us the plot. We have 0, 0. We have 0, 6. This is the letter K. That means this is 6 units. We have 0, 8, 0. This is L, and this must be 8 units. We'll draw the triangle. This is the right angle. It has to find the perimeter and the area. Well, the area is not a problem because we already have base times height. Half base times the height, 6. So 4 times 6 is 24 units squared because area is squared. Then perimeter, I need to find this length here. So we'll go 6 squared plus 8 squared equals C squared. 36, 64 equals C squared. 100 equals C squared. 10 equals C. So this is 10. Now to find the perimeter, we'll go 6 plus 8 plus 10, which is, well, 14 plus 10, 24 units. Go figure. This is one of those rare times when the perimeter is 24 and the area is 24. Do not expect this to be the way it is on the test because this is an unusual situation. It may be, but don't expect it. All right, next. 17. We've got a line here. We've got A, and then we got B, and we got C, and we got D, and we'll put little dots on the line here. All right, A is 12, B is this little tiny section here is 2, and then this section is 10. It says, what is the probability the point is not on BC? Well, probability is what you want over total. So what do we want? We want the area that is not BC. Well, I guess that would mean then what we're looking at is 12 and 10. So that area would be a total of 10 plus 12, 22. Over the total, well, what's the total distance? Well, that would mean you need to add in 2 as well. So we have 24. Now let's reduce this, divide both top and bottom by 2. You get 11 over 12. If you look down there, 11 over 12 is an answer. It is B. All right, let's go to 18. The Weather Channel covers a local weather 6 times per hour for a period of 3 minutes. If you change the Weather Channel at a random time, what is the probability that you will catch the local weather? Okay, well, what's the probability of catching it in 1 hour? All right, well, 3 minutes out of, wait, how many minutes are in an hour? Well, for most people, that's 60 minutes. If you have more than that, you need to share with me because I need more time as well. Okay, so this is the probability out of an hour. Okay, I know, out of an hour that I would catch it. Now, how many times in that hour am I going to be looking for the weather? I'm going to be looking for this 6 times. Okay, so there's all I got to do now is simplify. 6 goes in 6 one time, 6 goes in 60 10 times. This is 3 tenths or 0.3. And I believe that is on there as the letter H. And we will come back to you after a brief pause because I did such a great job. Okay, so I kind of did misread this a little bit. It's saying that in the course of a hour, they're going there'll be 3 minutes 6 times. So really in the course of an hour, the weather is going to be on there 18 minutes out of 60, which by the way, gives us right back to where we started. So it's all good. Okay, so now we'll clear this and we'll go to the next one, which is 19. Oh, the wonderful 19. 19 is lovely. Prime number must be a good problem. Maybe not. Hexagon. Here we go. I'll draw the hexagon. Yay, I drew a hexagon. Now draw a apothegm and put 7. All right. There is more than one way to do this. I'm going to go with the formula first. Area is equal to half the apothegm times the perimeter. Okay, so we know the apothegm, but we do not know a way to find the perimeter right now. So I have to do, I have to draw, did ask for the perimeter, the area, right? Yes, it does. Okay. I have to draw this triangle in. Now, if I do, this is going to turn out to be, because this up here at the top is 60 degrees, this is 60, this is 60, because that's a special property of a hexagon, that it makes 6 equilateral triangles. So, but if I split it, that means up here is the 30 degree and this one is the 60. Okay, so this is 60 and this is 30. All right, and this is a nice right angle. All right, so by the 30, 60, 90 rules, triangles from the past, okay, you got this one over here, you got 30, 60, well, across from 30 is 1, across from 60 is √3, and across from this is 2. Some of you may have used the little X idea, that still works. All right. So if 7 is equal to x √3, then x 7 is equal to x √3. This is the way some of you did this, okay? Then that means that this right down here is 7 over √3. All right, and I'm going to erase some of this so we have more room and it doesn't look so sloppy. Okay. All right, now, so we have that. However, in order to find the perimeter, I really need to know what the whole thing is. So let's multiply that by 2. So the base is 14 over √3. Notice I'm not taking and changing it right now to 14 √3 over 3. That is because it just will make it easier to put it in my calculator if you don't simplify it. So now let's put everything we need into the formula, given all that we have. All right, we have 1/2. We have the apothegm, which is 7. We have a way to find the perimeter. It is 14 over √3. And how many of those will we have? Well, let's see. Let's count them. 1, 2, 3, 4, 5, 6. Because in order to find the perimeter, you must add all sides. And if one side is 14 over √3, then we have 6 14 over √3s. And you can do it as 6 over 1 if you wish. Either way, you're going to need to multiply that out. When you do multiply that out, you should get on your calculator, I guess I'll pause and calculate it. Okay, and after some big thinking and calculator punching, I got 169.7 centimeters squared. Okay, so this is using the formula half AP. All right, I feel like I should at least also go over the other method. So I will draw this again. There's the hexagon that they give you. There's the apothegm, 7. All right, the other one is to again recognize, oops, I didn't realize it would do that. Okay, it will give you 6 equilateral triangles. So if I can take this one here, okay, and it's got 7 here, if I know this is the height, if I can find the base, okay, we could do it 1/2 base times height and find the area, then multiply that by 6. I can also find the base and do s squared squares of 3 over 4 times 6. Many different ways once you go about this, but the idea is if I find the area of this triangle, then I can multiply it by 6 and get the area for the hexagon as well. So if we go with the half base times height method, well, this is 7. In the same way that you found the bottom over here was 14 over √3, you'll have to do that process again. However, if now I want to find the area, it's half 14 over √3, that's the base, times the height. And then how many of those triangles will I have? Well, as you've seen earlier, 1, 2, 3, 4, 5, 6. I should have 6 of these. If I type this in my calculator, 14 times 7 times 6, enter, divided by, open parenthesis, 2 second square root of 3, close parenthesis, enter, you will also get 169.7. All right, there's still yet one more way to do this problem. So find a way that works for you. That's probably the most important thing I can tell you. And that is, I know this is 14 over the root 3. Once again, all three methods require you to find this. All right, but the other one would be using the formula for s squared square root of 3 over 4. That's the equilateral or triangle formula. But there will be how many of these? 6. All right, so now let's fill this in. 6 s squared is the 14 over root 3 squared square root of 3 over 4. Probably the hardest thing about this one will be making sure you put it in your calculator right. So what I would do is first do 14 over root 3 squared. So open parenthesis, 14 divided by second square root of 3. And you can do it other ways. And Mr. Flowers wants to point out, you could also put it in your calculator and do 14 squared, write that out, and then square root of 3 squared and get 3 and then divide it. That is true. There are lots of ways to do this. This is what makes math wonderful and a pain in the behind for those that don't like that. Okay, so there's my, get that as in a calculator, find out what this is as a decimal. Now I'm going to multiply it by 6 and by the square root of 3. So times 6 times second square root of 3. Press enter and now divide by 4. Press enter. And once again, I get the same answer of 169.7 centimeters squared. So as you can see, there are 3 ways to do this. Please find the one that works for you and stick with it and practice and practice and practice till you nail that process down. We only have one more problem to go. Number 20. All right, on 20, you have this square that it basically has these little curvature looking circles in it, and I'm trying to draw it. Hey, I'm feeling pretty good about that. And then this is shaded in here, okay? So this is shaded here. The question says, what is the probability that the dart thrown at the target shown will land in the shaded area? Round your answer to the nearest 10th of a percent. So what's the probability it'll land there? Okay, well, we don't have any numbers. So pick any numbers you want. I think I like to use 1 and 1. Okay, so the whole side is a distance of 2. All right, so the whole, what you want, again, probability is what you want over total. So what do I want? I want to know the area of the shaded section. Well, in order to find that, I'm going to need to take the area of the square, which is 2 times 2, 4, minus the area of the circle, because each of these little pieces here, okay, on the edges here, is a quarter of a circle. So 1, 2, 3, 4. If I put 4 of those together, I get 1 circle. So it is pi, well, what's the radius? 1 squared. Over the total, oh, the whole thing is, again, the square, which is 2 times 2, 4. If you type in your calculator 4 minus pi, enter, divided by 4, you should get 20, well, actually you should get 0.215. Okay, but then let's change that to a decimal percent, change it to a percent, and you get 21.5%. What did I do? I moved the decimal 2 places to the right. All right, with that, hopefully study, and you will do great. Hopefully this helps someone. Bye.